Okay. So today's topic is virtual networks. Okay. So virtual network means, so in the on-premises word, okay, you might have heard, you have this LAN, WAN concepts, correct? Huh? So LAN means it is local area network, WAN means it is wide area network. Okay. So LAN means the computers are interconnected within your office premises. Okay. If I want to write what is LAN and WAN, okay. Say for example, you are working in an office. This is your office, Bangalore office. Okay. So when you get inside the office, right, there are a lot of computers are interconnected. Lot of rows will be there. Okay, here people are sitting, here people are sitting, people are sitting, computers are there. Okay, and here one within the building only, within the here one rack will be there. Okay, all the computers are interconnected to the switch. Means each and every computer will have the connectivity within the office. Okay, this computer can talk to this computer and this computer can talk to this computer. Like if you have 100 computers, all the 100 computers will be able to have the communication. So that is there within the office. Okay, since this is there within the office, we will call it as local area network, LAN. It is called as local area network. So this is your Bangalore office. Bangalore, I will say Whitesfield. Whitesfield office. Imagine this is IBM building. And IBM has also got offices in Manyata Tech Park. IBM has also got offices in EGL. Okay, this is Manyata. This is EGL. Okay, this is also IBM office. This is also IBM office. So this all the three premises, okay, are there within the Bangalore location. Bangalore location. So the peoples who are sitting in Whitefield can talk to the IBM Manyata, and Manyata peoples can talk to the EGL, and EGL people can talk to the Whitefield. So if you look at here, the peoples who are sitting in IBM can talk to IBM Manyata here. With this help of Manyata, they can even talk to the EGL. Means there are everything is interconnected. See, Manyata can talk to Whitefield. Manyata can talk to EGL here. Whitefield can talk to Manyata. Whitefield can talk to EGL. So all the offices are interconnected. So this is called as WAN, wide area network. Maybe the IP address will be different here. Here the IP address is like 172.16.1.0/24. Maybe here 192.168.190.0/24, or maybe here like 172.16.2.0/24. So the IP address, the range of IP address or the subnet will be keep on varying from network to network. See here 192.168.1 is there, 1.0 is there. Here 192.168.2.0 is there. So here 1.0/24 separate network. Here 2.0 number is changing here, 2.0/24. So it is a separate network, and here 192 the class itself is separate. So this is called as wide area network. Okay, so if the communication is there within your premises, that is called as LAN. So this, if you separately take, this is a LAN, this is a LAN, this is also LAN. But when you club all together as a whole, see here, we will call it all together, combining all three, we'll call it as WAN. This is the on-premises word. Okay. Then if you go to the Azure, if you go to the Azure also you should have a network. Correct? Huh? So in the Azure, this LAN, whatever we call it as, this LAN will be named as Vnet. Vnet means it is virtual network. Why it is virtual? You are creating a network for you in the remote place, but you cannot see it, but you can feel it. That is why this is called as virtual. So, say for example, now you want to build a computer. You want to build a computer, okay, to host an application called Facebook. Since you are hosting an application called Facebook, you need the IP address for this computer. Since you want to give the IP address, so there should be a VNet. Without the VNet, you cannot create the IP address. You cannot give the IP address. Correct? Na? That is why we have a concept called virtual network. Okay, the virtual network is nothing but it is one of the network services in the Azure. Okay, used to place a computer in the network in the cloud data center. Okay, so now let me go to this is the basics. You got the thing right? Have you understood the basics now? What is LAN, WAN and VNet? Both are same only. Okay, one more thing. So say for example you are in the IBM office here on premises. This is on premises at your office. This is on premises IBM facility. You have somewhere in the cloud data center, you have Azure cloud, and here you are creating a VNet. The VNet will be represented like this in the cloud. The representation of the VNet will be like this. Okay, so here you are placing a computer. The IP address of the computer is 192.168.1.10. Here you are having a computer. Okay, and this computer IP is 172.16.1.10/1.10. See, to establish the connection between your office and the cloud, or between your two offices, you need to have a router. Okay, that's the router. And router is an intelligent device used to establish the connection between two different facilities or two different network. And router expects at the both the node different IP addresses range. That is why this side it is 192 and this side it is 172. Now this is the basics. Okay, so what we will do, with the help of maybe some lease line or something, we will establish the connection between your Azure data center and the on-premises data center. So in the on-premises I am calling it as LAN, but in the cloud I am calling it as VNet. This is how the actual the solution will be there. Okay, so let me go back to the slide now and let us explain the basics from here. Okay, let me know if you are able to see the screen. Hope you are able to see the screen now, right? So today's concept is the virtual network. So if you look at here, virtual network means it is one of the network services in the cloud, okay, used to represent your own network in the cloud. If somebody asks you what is your network in the cloud, you can tell we have a VNet with the range of IP address called 192.168.1.10, or any number you can tell. Okay, not a problem. So let me take a color. Yeah, let me go with this. Yeah, so you can tell you have a VNet. Maybe the VNet name is VNet01 and the address space is like 192.168.1.0.0/16. So if I write /16, if you remember yesterday I told you, you can connect up to 65,534 or something IP addresses will be there. Means these many computers you can connect. Okay. So that is what we call it. And the representation of the VNet in the cloud, you see, this is the picture. I have written the same picture. I have written like one box. I have written. Okay. So I have written like this. If you write like this, this is called as VNet. Why do we need this? To place the computers or to place the servers or to place the resources in the cloud, okay, to establish the connection between your on-premises network. Okay, so we also have other network resources in the Azure. So some of the other resources in the Azure, you can see it here. We have virtual network, we just discussed, and we have IP addresses. So when you have virtual network, you are going to define what is my address space. This is your address space. So then I told you, you have around 65,534 IP addresses. That is why I have mentioned as IP addresses. And within the IP address, if whatever you have defined in this VNet, they all will be private IP address, VNet. You also have public IP. Public IP, you cannot create a VNet. Public IP can be purchasable. Okay, you can have to purchase them. So I will tell you how to create a public IP and how to associate that public IP to the virtual machines. So why we need public IP? Say for example, you have a computer here. Yesterday we have created a computer, na ecom-vm01. See, this is there in Western Europe, and we are sitting here in India, correct na? And we want to establish the connection and to access the VM means either I should have a private connectivity or I should have a public connectivity. I don't have any connectivity between my computer at my house and the virtual machine which is sitting in the Western Europe. That is why what I am using, I am leveraging the internet. I am using the internet, okay, the public network with the help of a public IP. Okay, I have assigned a public IP here, PIP. Okay, public IP. And yesterday I told you, if you have a public IP, your computer is exposed to the internet. Anybody can access. That is why I can able to connect an RDP to the server and I'm able to log into the computer with the help of the public IP. So public IP is chargeable IP. Public IP we have, it is a chargeable IP. You have to pay for the IP address. It's a chargeable IP. Next is load balancer. So now you know there are two resources in the network. One is virtual network. You know why do we need virtual network? Virtual network means it is the logical representation of your network in the cloud. Why do we need virtual network? In order to get the IP address to give it to the servers. Done. Then when I talk about IP addresses, there are two types of IP addresses. One is private IP, which is there in your virtual network, VNet. Another one is public IP, which can be purchased in the Azure. It is a chargeable IP. Okay, but VNet is not chargeable. IP address is not chargeable. Only the public IP is chargeable. Okay. Then you have Azure load balancer. So load balancer means it is an high availability device. Say for example, so load balancer, we will read it thoroughly in the upcoming classes, but now today just to give the insights, I'm just just to give the overview, I'm just telling. Say for example, you have an application server here. This is an application server, and it is hosting an this has got an IP address like 192.168.1.10. Okay, 1.10, and the application name is facebook.com. And some user is sitting here and he is trying to access this one, and that connection is coming here and getting the application, and it is giving back to this computer via internet. Imagine for some reason this server, the application server, this server gets shut down, or maybe in between the data center and your home the network connectivity lost, or maybe server get restarted, then the person who is trying to access the application, he will lose this Facebook application, he will not be able to log into the application. So it is a one point of failure, correct, huh? So to come out of this issue, we have a concept, Microsoft has given a concept called load balancer. So this load balancer, this is a load balancer, okay. So what Microsoft is telling, you create a load balancer with a IP address like 192.168.1.10, and you can even name it, you can give a DNS name for this, facebook.com, okay, and you create a backend pool, okay. The backend pool is this one, okay, and you add how many number of application servers you wanted behind this backend pool. Say for example, you have an application server here, you have an application server here, you have an application server here, and you add 3 servers, at least 2 servers behind this backend pool, and you can give any IP address for this one. Maybe you can give 192.168.1.1, this is 1.2, this is 1.3, but you are not directly accessing the application using this 192.168.1.1 or 1.2 or 1.3, but instead what you are trying to do, you are accessing the application using the load balancer IP. So when you send www.facebook.com, the query will be going and hitting in the load balancer, because if you see here, the facebook.com is the name of this load balancer IP address, correct now. So when somebody type www.facebook.com, the request is passing to the load balancer, it is reaching the load balancer here, and the load balancer has got a backend pool here. In the backend pool you have 3 servers, okay, and 3 servers are having the same application called Facebook. Due to some reason this computer gets crashed, you still have 2 computers here or 2 servers here with the same application. Your load balancer is an intelligent device. Based on the rules, it will now forward the query to this, from here to here it will go. Means you are only hitting the facebook.com, the load balancer. The load balancer is an intelligence thing, okay. You will create a rules there, okay. What kind of load balancing I have to do? Do I need to send one request at one server different time, or do I need to always send for this one? Whenever this is not working, then send it to 2. Whenever both 1 and 2 is not working, then send it to 3. Like that you can create the rules in the load balancer, okay. So if you do like this, even though there are 3 computers, or even though 2 computers are shut down also, you have the 3rd computer with the same application, and your application will be up and running all the time. So Microsoft will give you, if you use this kind of load balancer, they will give you 6 digits of 9, okay. 99.9999% of SLA means your application will be always up and running 99.9999% of the time. So this gives high availability, very minimal downtime. If it is crossing, like if for some reason if it is crossing like less 99 point instead of 99988, if it comes, then you can penalize Microsoft. Microsoft will give you penalty because they are breaching the commitment here, SLA. Means SLA, they will tell you, if you use load balancer, we will give you 99.9999% of the uptime. For some reason at the Microsoft data center level there was some issue, okay, and they were not able to give the 99.9999% of the SLA uptime. If it is 99.99 or 98 also, you can penalize them. They will pay you a lot of penalty to you. They have to give money to you because your business got interrupted. Okay, you have directly impacted on the finance because your machine application was down. Okay, this is called as load balancer. We will study further. This is one of the important device and we will talk about it there. Okay, and the application gateway. So application gateway is one of the important thing actually. Okay, so this is used to mask the identity of a computer, means people should not know what exactly the IP address of the application server. They are using, like they will tell www.facebook.com and that is hitting like 192.168.1.10, but indirectly this application gateway is there, now that will change the IP address and respond back, so it will not reveal the real identity. Okay, that is called as application gateway. So traffic manager means traffic manager is one of the resource. Okay, so for example, Facebook is a global application, correct? Huh? Facebook is a global application and that is there everywhere over the world. Imagine you are working today in India. You have yesterday, today you are logging into facebook.com. You are sitting in India. When you have this traffic manager, so what it will do, it has got a capability of identifying from which region the traffic is originated. Okay, and it will send to that particular respective servers. So when I say facebook.com, it is not a single server, correct? If you are in India, okay, okay, so you will have somewhere one Facebook server here. And if you go to America somewhere, you have one application server here. And if you go to Australia, maybe you have one more application server here. So you are placing the traffic manager here. And traffic manager has gotten a name called facebook.com. So when you type, being in India, if you type www.facebook.com, this traffic manager will sense and understand, oh, this user is in India region. Then let me send a query to the Indian server. Then tomorrow on the business trip you are going to USA, America, you are traveling, and there you just hold your phone and just go to www.facebook.com. So this traffic manager detect immediately, oh, there is a location or the region change, the user is not in India now, he is in USA, then I should not send the traffic to the India facebook.com because the distance between India and the traffic manager, I mean the person who's in the USA, correct? If you see the distance here, this is huge. This is not the physical distance. This is about the network distance. Lot many routers, lot many switches, lot many junctions will be coming here. So that is delaying the performance. So to overcome from the delayed performance, this traffic manager will sense this person is there in the USA region. Then I should not send this to the Indian Facebook server. I should send the traffic to the USA Facebook server. Then it will send the query to the American Facebook server. So this is called as traffic manager. Okay, there are multiple rules are there. We will discuss further. Okay, you should know what is traffic manager. Why am I explaining like this? Because now we will start creating the resumes. When you just start creating the resume, we have mentioned these kind of things there. You should understand what exactly this traffic manager means, what is public IP, what is Vnet, what is application gateway, okay, all these things. And then we'll talk about this network security groups, NSGs. So this network security groups are nothing but the firewalls. Okay, so network security groups means these are all the kind of controls or the firewalls which can be applied at the subnet level or the virtual machine network interface card level. Means the network security groups can be, NSGs can be applied at the two level. One is at the NIC card level, another one is at the subnet level. So if you want the computer specific things, then you can apply the NSG at the network interface card of the computer. If you want at the overall subnet, say for example this is a VNet and I am creating a subnet here. So I have /16 now. So what I will do, I will create a subnet 01 with this 192.168.1.0/24. This is one subnet. Now 192.168.1.0 2.0/24. This is a separate subnet. See 1.0, 2.0/24/24 only I'm writing, means 254 IP addresses. I'm separating this 65,534/6 is a single network. This /16 is there. Now I'm just dividing that. See here 8, here 8 is there. Correct na? This is 8 bit, this is 8 bit, right? So up to the like till it becomes 254.254, you can create n number of networks, not a problem. Okay, so 32 bit is there, 16 bit is there for the network, and 16 bit is there for the host. Okay, then the last subnet would be like this: 192.168.254.254/24 will be the last subnet in this /16 network. Okay, so the traffic, the NSGs can be applied to this subnet level. Once you apply at the subnet level, the traffic will be allowed or denied for the entire subnet. In this case, all the 254 computers will have the same rules, firewall rules applied. We will discuss that further. And forced tunnel. If you want to dedicatedly tell the traffic should flow between this particular tunnel, you can create a forced tunnel. Okay, like whenever there is a VIP passing is happening, the traffic, they will redirect the traffic, correct? Not to just avoid the thing. Means that the police will force you to take another route, okay, to avoid the traffic. The same thing here. Forced tunneling means the critical business application related things can be forced via particular tunnel. That is called as forced tunnel. And we have VNets, regional VNets. So by default, no two VNets will have the communication. So let me go back here. I was explaining, na, like you have IBM office in Manyata, you have IBM office in Whitesfield, and in also EGL, correct? So by default, no connectivity will be there. By default, no connectivity will be there. No connectivity will be there in the on-premises. What you have to do, you have to put the router and you have to enable, okay, traffic between this one to this one should flow via this router, you have to tell. You see here also same, the traffic between this one and this one should flow via this router. Same thing here, the traffic between your Manyata and EGL, this is Whitesfield, okay, should flow via this router. Like this, you have to make the network configuration. That is when this network team will be coming to picture. Network team means the people who have done CCNA, CCNP, they will come to picture. They will log into the router. They'll enable the routing tables. They will enable the OSPF or AGRP. There are some routing protocols are there. They will enable, and they will mention in the router traffic from Manyata to Whitesfield should go via this particular IP address. See, like that they will put routes for all the locations. So same way, by default in the cloud also, in the cloud, if you have VNets, if you have two VNets, there won't be any connectivity. Okay, either it is within the region like Western Europe or Northern Europe, or sometimes what happens in the Western Europe only you have two VNets. Okay, this is Western Europe. Okay, so by default there is no connectivity between these two within the region Western Europe only, or if you have Northern Europe, another DR region, by default there is no connectivity between two virtual network. Either they are in the same region or they are in the different region. Then we have a concept called Vnet peering. Vnet peering. Okay, means you are going to establish the connectivity between two VNets manually. You will tell, okay, hey you, I have a network here which is a 192.168.1.0/24, and you have 172.16.1.0/24, and you are going to create peering peering between these two Vnets. If the Vnets are within the region, if the Vnets are within the region, Western Europe, then we call it as local Vnet peering. Vnet peering. So, if the Vnets are between the two different regions, say for example, now you have a Vnet here, and that is in Northern Europe. Now you want to establish the connection between your Western Europe and Northern Europe. Such kind of peering we call it as global Vnet peering. Okay, so we will also do that. I will show you, maybe I don't know whether we can do it today, but maybe tomorrow we will do the lab, right? At that time you will understand. Okay, that is called as the regional Vnets. Private talk between Azure regions will call it as, okay, and Vnet peering and all is there. Okay, and VPN connection, I mean to create the peering we will use this VPN connections only, like point to point and point to site. Okay, so let me also explain you this point to point and point to site. Okay, so since I'm opening it here, okay, so in the VPN there are two types of VPN. Okay, let me do one thing. So this is your, yeah, this is your cloud. Okay, and maybe you have your on-premises here, big offices are there. Okay, the connectivity between, you may have a question, how will my computer will talk to the data center or the servers which are there in the cloud. So that is called as express route. We have a connectivity between your on-premises and your cloud. We will call it as express route. See, just to access one application, you can use the private public IP, correct? But public IP, if you use in the real-time office work, it will be security risk. That is why we will not use public IP there. So then we will talk to maybe Jio or Airtel, and we will establish a private connection between your cloud virtual network here and between your office network. Any communication that goes via these two regions will be passing through a secured tunnel. That secured tunnel is nothing but express route. So express route is nothing but the connectivity between two different regions. Either it is in the cloud or it is in the on-premise, or between the on-premises and the cloud. Anything is fine. That is called as express route. So express route is nothing but a dedicated channel to establish the connection between two different nodes. Either the nodes can be in the cloud or can be in the on-premises or between the cloud and on-premises. That is called as express route. Okay. Now you have a concept called VPN. So there are two types. What is VPN? What is VPN, guys? VPN means it is virtual private network. Is it correct?
Yes, sir.
Yeah. So use it to establish the connection between 2 points. Either it can be from your office to another office or from your home to your office. Correct? So there are two types of VPNs actually. Okay. One is point to point. Another one is point to site. Sorry. 1 minute. I think I just wrongly did it. Site to site and point to site. Sorry. This is site to site and point to site. Okay. Point to site. Another one is site to site. This is very, very important. They will ask these kind of questions. In the Azure, nobody knows what to ask because it's a newly evolving technology. They will ask only few areas. Okay, these are the areas only they'll ask the questions. So point to site means, so you have office here and you are working from home today. and you have a laptop. You are establishing with the help of a VPN connect, a VPN client, either it can be Cisco any connect, or maybe your 40 clients, 40 client VPN tools. You are establishing the connection between your laptop to your office to have the connection securely transacted. Okay, so whatever the data you use, you are trying to access now using public network. See, at your home you have the internet, at your office you have the private network, but if you are transacted the data in the public network, it is a security risk. So this VPN will help you to establish the connection between your public network, which is your home network, to the private network, which is your office network. So any data that you transfer within this pipe or this tunnel, that will be end to end encrypted and secure and sent. Okay, that is called as VPN. If you establish the connectivity between your laptop to your office network, that is called as point to site. Okay, and another one is there. Okay, you have two offices, one is in Hyderabad, another one is Bangalore. So to establish the connection between two different sites, okay, sometimes we will use VPN instead of express route. This connection we will call it as site to site, because either Bangalore is a different site, Hyderabad is a different site. Correct. And you are trying to establish the connectivity using the VPN, and that is why we'll call it as site to site VPN. Okay, that is the difference between point to point and point to site. Okay, see, this is how the connectivity looks like. If you look at here, this is your on premises. See, I told you now all the components are here. This is your on premises, and see, the on premises network is only the dot, and you don't have this kind of expression. See, this kind of tags are not there. This is your on prem, and see, in the on premises you have application gateway, application servers, everything is there. And this is your cloud. This is your cloud, means Azure. And in the Azure, I told you, this is your hub network. So you are, with the help of this express route, see, this is express route. I told you, to establish your connection between your on-premises and the cloud, or between the cloud regions also. Okay, or between the on-premises also, or in between the on-premises and the cloud also, I told you. Correct. This is express route. See, and where this Vnet peering comes, sir. See here, you have in the Azure you have three Vnets. One is hub Vnet, this is spoke Vnet, this is called as spokes Vnet. And I told you, between the two Vnets there is no connectivity. So here what they are trying to do, they are trying to do hub and spoke model. Hub means one main one, spoke means multiple, spoke 1, spoke 2, like this. And see, the peering is happened here. This is called as Vnet peering. Now, say for example, the person who is sitting in this computer, he want to talk to this jump box. You can see the connectivity will go to your hub network, and from the hub network it will go to the spokes network. Okay, so now the person who is sitting here in the spokes 2 can talk to the hub spoke 1, and spoke 1 talk to the spoke 2 via hub network, this hub network. Okay, this is what the representation of the on-premises and the Azure, the connectivity. Let me close this, discard it, and if you want to take a snap, you can take. If you want to take a picture, just to recall how network connectivity will be there. It may be in your, now you can imagine. So this is my office location, Bangalore. I have 10 servers at the on-premises. and I have a connectivity between my Azure network. How the connectivity is there? The connectivity is there via express route, this express route. So this is express route. So with the help of express route, you have the connectivity between your on-premises and the cloud. And within the cloud, we have Vnet peering. And this is called as hub and spoke. Hub means in the cycle wheel, you have seen the hub, na? All many spokes will be there, correct, na? So the spokes will connect between your rim and the hub. The hub is very, very important. Any person you want to talk means the hub is very, very important because that holds everyone's. Correct, na? The same fashion here. And you see here, local VNet peering means the peering between the two VNets of the same region. Okay. Global VNet peering means enabling the communication between two VNets of different region. Okay. That is called as peering. You can see here, Azure you have VNet 01 and VNet 02 and the peering see, and both are in the same RG, but you see the connectivity is established. And if you look at below, the network traffic between the peer VNet is private. Means if the connectivity, if you do the connection established, okay, if you establish the connection between two VNets, any traffic that's flow between this one and this one is private and not public. It is private network only. There is no network, internet will come to picture. And low latency means super speed will be there. There is no latency. Okay, very low latency means performance will be good. High bandwidth. Since the low latency is there, bandwidth will be high. Or bandwidth is high, that is why low latency is there. How would they manage? Microsoft manages with the backbone network. See, Microsoft is there, no? Microsoft has got 52 regions, I was telling you, correct? Azure has got 52 regions. So what they have done, between the regions, they have put their own cables in the oceans. 1,000 meters, lakhs together kilometers, they have put their own cables between their data centers. Okay. So connectivity, their own network is there with huge network bandwidth. Okay, we call their own cabling which is laid in the ocean between the regions, that is called as backbone network. Means they will not be relay or they will not be depend on someone's network. Okay, they have their own network. They will not be dependent on the Geo, or they will not be dependent on the Touchtel, they will not be dependent on the Airtel. Okay, because they only have digged the land and they have digged the they have put the cables in the ocean between the 52 data centers, okay, or 52 regions. That is that region connectivity of Microsoft we call it as Microsoft backbone network. That is very, very strong, and it is a very huge bandwidth. Okay, and ability to communicate and transfer the data across all the regions means across 54 regions you can have the connectivity established just by doing the VNet peering. And the transfer is fully encrypted. Whatever data get transferred between two regions or between two VNets, everything is fully end-to-end encrypted. 256 hashing algorithms are there. Okay, 256 256 bit encryption technologies are there. Any data that is passing between the regions, everything is encrypted. Means nobody will be decode this and read the data what exactly it passing. So encryption means what, right? When you say hi, hello, how are you, it will send its own language. 0 1 2 3 4 5 6 1 2 3 4 5 6 1 9 years, like that. It will send in a different language where the common people or even the intelligent devices will not be decode it. That is a 256 bits encryption technology they uses. It's very very strong. Even Microsoft will not be able to see what exactly the data is flowing. Such a level of security will be there. Okay, and peering is not transitive. Not transitive means if you establish the connection. See, if you see here, it is a two-way. I am showing the arrow both the way. You have to manually tell Vnet 1, you have to create two peering actually. You can tell, okay, Vnet 1 tag to Vnet 2 and Vnet 2 can talk to Vnet 1. Like that you have to create a pairing manually. If you just create Vnet pairing from Vnet 1 to Vnet 2, only the Vnet 1 can talk to the Vnet 2, but Vnet 2 cannot be able to talk to the Vnet 1. That is called as non-transitive. Transitive means I am talking to you, you can also talking to me. That is called as transitive. I am telling you hi. You are similarly from the other side you are telling hi, hello. There is a handshake happens. The two-way communication happens. That is called as transitive. Non-transitive means I will tell hi. You will not even respond. You will chumma go. That is called as non-transitive. Okay? One-way communication. If you want to do the communication, you have to establish both the sides. You have to go to Vnet 1 and establish a connection between Vnet 2. Then you have to go to Vnet 2 and establish a connection between Vnet 2 to Vnet 1. That is called as non-transitive. See here, Vnet 01 and Vnet 02. I am trying to create, see both are different network 10.10.00/16, 192.168.1.0/24, right? And now I am establishing the connectivity, and if you look at, we have the NSG here. See, the NSG is here. The NSG is added where? To the subnet. See, this is a VNet, and you have created a subnet, here. See, this is a subnet, correct? Huh? And where you have attached NSG, you have attached to the subnet. Means the entire computer, the /24 means 254 computers will be having this NSG. So if you want to tell, you want to do the RDP, you have to go to this NSG and allow port number 3389 from this 10.10.00/16 allow. Like that you can create a rule here in the NSG. Then anybody from 10.10.0/16 network can RDP to the server remotely connection. Otherwise, no. That is called as NSG. Okay, and these things we learned yesterday, right? So IP addresses, classes and all. That's all. So that is about the introduction, and that is about the overall theory of virtual network and other network resources which will be coming to the coming in the Azure, and also how the connectivity between your on-premises and the Azure is established, and how the connectivity is established in the on-premise cloud. You have to tell like this. See, when you have office at the on-premises, when you have offices at the cloud together, then we call it as hybrid. Hybrid means you have both on-premises as well as cloud data centers. How the connectivity is established between your on-premises and the cloud is using an express route. You can tell we have offices, ours is an hybrid scenario where we have data center in our own office, and we have also our extended network is there in cloud Microsoft Azure, and the connectivity is established using an express route connectivity. And in the cloud we have this hub and spoke model. We have a hub network, okay, with a gateway subnet, okay, and that hub will have the connectivity between multiple spokes. So we have multiple spokes for production workload, and we have for non-production workload we have multiple spokes, and all the spokes have the connectivity between each other by using a VNet peering between my hub and spoke virtual networks. If you talk like this, interviewer will not ask any questions, because he know that you know the concept, and he'll just pass on to the next options. Okay, that is how you have to speak, and these are all the things you should keep it in your mind. And VNet peering we learned, it is not transitive, it is by default it is non-transitive. You can enable the connection, and there are two types of VNet connections are there. local Vnet peering and global Vnet peering. Okay, and the benefits of this. And you also learned about the Microsoft Backbone Network. The Microsoft Backbone Network is nothing but Microsoft has laid down their own cable between the data centers, or any connection that flows in that their own connection, that is called as backbone network. And VNet peering you see, and also you learnt about the NSGs. NSGs can be applied at two level. One is network interface card level, another one is the subnet level. And the IP address we discussed. Okay. So
Thank you.
any questions, guys? If no questions, let me quickly stop the recording.